Hey everyone, and welcome to section 5.2, talking about properties of exponents, and we're also going to talk about scientific notation in the next video. To get started, we want to remember, exponential a to the n, or read as a to the nth power, where a is a real number and n is a positive integer, is defined to be the number a times itself n times. So for instance, negative 8 to the fourth power is negative 8 times negative 8 times negative 8 times negative 8, which is equal to 4096. And it doesn't have to be whole numbers that you're raising to an nth power. It can be any real number. So 2.6 to the fifth power is 2.6 times 2.6 times 2.6 times 2.6 times 2.6. Which is 118.81376. So that's a quick refresher. We're going to look at the properties of exponents now that are going to be super useful for us. All right. Suppose that a and b are non-zero real numbers and m and n are positive integers. The first property that we have states a to the m power times a to the n power equals a to the m plus n power. So what does this mean? This means basically when you have two exponentials that are being multiplied together that have the same base, what you're going to do is add the exponents. Next up, we have a kind of similar idea, but with division. So if you're dividing two exponentials, a to the m divided by a to the n is equal to a to the m minus n. So in other words, if you're taking the same base exponential and you're dividing it by the same base exponential, you are subtracting the exponents. Namely, you're taking the exponent of the denominator away from the exponent of the numerator. Thirdly, we have a to the m all raised to the n power, so we're taking a power to another power. And this is saying that when I do that, I have to multiply the exponents together. So an exponential to an exponent, you can just write it as a single regular exponential with the exponents multiplied together. Next up, we have a to the m times b to the m, and that's equal to ab all raised to the m power. What this means is you can collect two numbers, even if they're different, under the same exponent. So any base raised to the same exponent times any base raised to the same exponent, you can collect those together under the parentheses. Here we have x to the 12th times x to the 7th. These are the same base. So what I'm going to be doing is adding my exponents together. And I get x to the 19th power. Next up, I have 10 times 10 to the x. Remember that when we see a number by itself, it secretly has an exponent of 1. So we have the same base being multiplied together, 10 and 10. We've got to add the exponents. So this is 10 to the 1 plus x, or if you're a snob, 10 to the x plus 1. But you can still do this even if you have coefficients out front. So let's take a look at that, because what we can do is rearrange things using the commutative property. And again, we have the same base being multiplied together, so we're adding exponents to get z to the 8th power. Here we've got b to the 5th times b to the 9th times b to the 5th again. Doesn't matter if you're multiplying together 3 or 4 or any number you choose, you still do the same thing. So we're still just adding the exponent together to get b to the 19th power. So that's the first batch of simplifying, not too bad. Next up, we have these guys here, x to the 9th over x to the 5th. This is going to be equal to x to the 9 minus 5, which would be x to the 4 power. For my second expression, I'm doing the same thing again. Doesn't really matter that they're actual numbers. This is 3 to the 10 minus 1, or 3 to the 9 power. Okay, we have x to the 7th divided by x to the 7th. This would be, again, we're subtracting, x to the 7th minus 7. We would get x to the 0. So I'm going to put a pin in that for the time being. We'll come back and talk about 0 exponents shortly. And then fourth, we have this creature here, a squared times b to the 4th divided by b cubed. The only same exponent that we have is the b's. So for those guys, I'm subtracting 3 from 4. So give me a squared times b to the 4 minus 3 equals a squared b to the 1st. Next up, we're doing powers to powers. Not really too bad. When I raise an exponential to a power, I multiply the exponents. Okay, so x squared squared is going to be x to the 2 times 2, or x to the 4th. Y to the 3rd raised to the 4th power gives me y to the 3 times 4, or y to the 12. Negative 3 to the 3rd raised to the 2nd power gives me negative 3 to the 3 times 2, or negative 3 to the 6th power. Finally here, we got a bunch of stuff in this last guy here, but we're primarily interested at the moment in raising powers to powers. So we'll have x squared, y squared, z cubed, and then I'm multiplying the two exponents here. So that would be raised to the 10th power. All right, next up, some practice with collecting exponentials under the same parentheses. So 3 to the 5th times 6 to the 5th. I can rewrite that as 3 times 6 to the 5th power, or 18 to the 5th power. Next up, we have 2 to the 6th times 6 to the 5th. Okay, so different base and different exponents. But here's a little trick. I know that 6 is 5 plus 1, surprise, surprise. So I can split 2 to the 6th up as 2 times 2 to the 5th. Then I can collect the 2 to the 5th and 6 to the 5th under the same parentheses. Now I get 2 times 12 to the 5th. And I would leave it like that because the 2 over here is not inside with the exponent. Third, we can do the same thing with variables. Okay, so it's not a big deal. Voila, not so bad. And lastly, we're going to do the same trick that we did on the second one. Namely, we're going to say x times x cubed, y cubed, z cubed is equal to x times xyz all to the 3rd power. All right, now remember how I said we were going to talk about this again? So here we have x to the 7th divided by x to the 7th, and we said previously that it was x to the 0. But on the other hand, x to the 7th and x to the 7th are the same thing, and we know any number divided by itself is equal to 1. So if we want this notion of adding and subtracting exponents to be consistent, then we have to define x to the 0 to be 1. So any non-zero value raised to a 0 exponent is equal to 1. And we can extend it even a little bit further, because if we are allowing for 0 exponents and we're doing adding and subtracting of exponents, there's no reason why we shouldn't be able to do integer exponents. So on one hand, this is equal to x to the 7 minus 9, or x to the negative 2. But on the other hand, If we're super clever, we can rewrite the denominator as x to the 7th times x squared. And it would check out because x to the 7th times x squared, you'd add the exponents, you get 9. But hey, if x is not equal to 0, we can divide out that x to the 7th term, leaving us with 1 over x squared. So if we want to keep our rules consistent and we want everything to work the way we want it to, then we're going to have to define a number to a negative exponent to simply be the reciprocal. So as before, we saw x to the negative 2 is really 1 over x squared. 10 to the negative 3 is the reciprocal of 10, which is equal to 1 over 10 to the third, or 1 over 1,000. And here we have a negative exponent in the denominator. But I know that a negative exponent means I'm taking the reciprocal. Oh, so this ends up being 1 over, what's the reciprocal of y to the negative 3? It's 1 over y to the third. But I know that when I divide by a fraction, I'm really multiplying by its reciprocal. And we get y to the third power. And last up, we have a fraction that is x over y raised to the negative 2 power. And since it has a negative exponent, if we wanted to rewrite it with a positive one, we'd have to write 1 over x over y, which is a complex fraction. But the shortcut here, and you might have gathered it by watching this example unfolds, you can just switch the numerator and denominator, right? That's what the reciprocal is. All right, challenge time. We've got these last 3 beastly examples to look at, so let's go. Up first, we have 3x squared y to the 4th times 2x to the 5th y to the 6th. We're going to combine a bunch of properties in tandem. So first, I'm going to rewrite this as 3x squared to the 4th y to the 4th. And I'm going to do a similar kind of thing here. So I have 2x to the 5th y to the 6th. And then again, in the parentheses, I have to apply the exponent to each number. So I have 3 to the 4th times x squared to the 4th power. I multiply the exponents, times y to the 4th times 2 to the 6th x to the 5 times 6 times y to the 6th. And let's see. Okay, so this is pretty terrible. So we have some similar bases here, or same bases here, rather. So 3 to the 4th and 2 to the 6th, I'm just going to leave as is. We have x to the 2 times 4 is 8, so x to the 8 times y to the 4th times x to the 5 times 6 is 30, y to the 6th. And then we are multiplying the guys with the same base. So we add the exponents, and that's going to give us x to the 38 power times y to the 10 power. All right, and as if we weren't sweating badly enough already, we have a fraction now, but we'll do our best. So upstairs, we have x to the 3rd raised to the 4th power. This is like multiplying the exponents. Then we have x to the negative 2 raised to the 5th power, so this would be negative 2 times 5. Downstairs, we have x to the 6th raised to the 5th power. Simplify a little bit. And now we are going to be adding and subtracting our exponents. So upstairs, I'm multiplying x to the 12th and x to the negative 10 together. So I would add 12 and negative 10. And then downstairs, I have x to the 30, so I have to subtract 30. So all told, I have x to the negative 28. All right, last one. So for the first fraction, what I'm going to do is apply this exponent to the numerator and denominator, which is a consequence of the other properties. And then I have a negative 1, but I already have a fraction. So I'm just going to take the reciprocal, save myself some headache. Now, since the entire expression in the numerator is getting squared, and the denominator as well, don't forget, you have to apply this exponent to each of the individual factors. So I would have 2 squared, which is 4, and then x squared. And I have y cubed squared, multiply the exponents. Okay, and downstairs I would have x to the 3rd raised to the 2nd, which would be x to the 6th. And then I would multiply the exponents here. All right, so let's see, I'm going to simplify here. I have the 1/12 I can't do anything with, but I have an x to the 3rd and an x to the 1st downstairs. So I have x to the 3 minus 1. Then I have y to the negative 1 and a y 3rd downstairs, so I have y to the negative 1 minus 3. I'm going to do a similar thing over here, so I have 4 times x squared divided by x to the 6 means we would have x to the 2 minus 6. And then we would have y to the 6 divided by y to the negative 4th. We want to be careful of our signs. We're subtracting a negative exponent. All right, so I'm going to collect these two guys together, the 4 and the 12. And then I am going to simplify. And while I'm at it, I'm going to put the x's together and the y's. And there we have 1/3 x to the negative 2 times y to the 6th. If you felt okay about that, congratulations. You're on your way to becoming a ninja as far as properties of exponents are concerned. If you're not comfortable with it, go through the steps again carefully and see where it is you're getting tripped up. Go back and look at the properties and see specifically what is being applied in each instance. Otherwise, that's it for this video. Next up, we're going to be talking about multiplying